All right. 12.3. We're going to talk about inscribed angles. When did you guys get so needy all of a sudden?
Is this hard?
No. It's easy. There's really only one thing to remember about inscribed. That doesn't happen quite as much with this. All right, so I want to have a quick review before we talk about inscribed angles. So let's remember we talked a little bit about central angles when we talked about chords and arcs. So I just want to remember how the central angle is related to the arc. So a central angle has the vertex at the center. Central angle, vertex at the center. Do we remember how the angle and the arc are related for central angles? So if we talked about how many degrees this angle was and how many degrees this arc was. For a central angle, they're the same. Oh, so I think you're thinking you're ahead of us. That's what we're going to talk about today. So no worries. So the vertex at the center, the angle, and the arc are equal. So if this is a 50-degree angle, this is a 50-degree arc. This is an 80-degree angle, that's an 80-degree arc. All right, so for inscribed angles, draw a picture there. Here's our circle. For our inscribed angles, our vertex is on the circle. So we look like this. So I'll call this A, B, C. And Carolyn gave us a preview here. The angle is half the arc. And we call this arc the intercepted arc. So our vertex is here on the circle. Arc AC is the intercepted arc. And the angle, the measure of the angle is half the arc. So in symbols, we'd say the measure of angle ABC is 1/2 the measure of arc AC. And if we turn it around, if we thought about it the other way, the arc, the measure of arc AC, how would we say that's related to the angle? 2, twice the measure of angle ABC. And I like to draw just a little diagram. To go from the angle to the arc, we multiply by 2. And to go from the arc to the angle, we divide by 2. So that's all we have to remember about intercepted arcs and inscribed angles. Go from the angle to the arc, multiply by 2. Go from the arc to the angle, divide by 2. And we'll kind of extend it a little bit, but that's our basic rule for today. All right, questions on inscribed angles, what they are, and how they're related to the arc. Okay, let's look at an example. I think the fun thing about chapter 12 is being able to draw circles all the time. All right, so I'm going to call this point A, this point B, this point C, and we're going to say this angle is B degrees. This arc is 56 degrees. This arc is A degrees. And this angle is 52 degrees. And we want to find A and B. So it can be helpful if you have highlighters or colored pencils. I know a lot of students do this when we work on this section. I'm going to highlight this angle B. I'm going to highlight that in red. There's angle B. Well, do we know an intercept and arc there? Does angle B intercept an arc? Yeah. What's the arc that it intercepts? 56. So I can say I go from the arc to the angle. How do I go from the arc to the angle? Divide by 2. So B is just 56 divided by 2, or 28 degrees. All right, now I'm going to highlight this other angle that we have, that we know here. There is the other angle. Does that angle, so what arc does that angle intercept? Arc AC. Can we figure out how long arc AC is?
Yeah, just
Multiply by 2 to get to the arc. So arc AC, the measure of arc AC is 52 times 2, which is 104 degrees. So if this whole thing is 104 and this piece is 56, how do we find this missing part? 104 minus 56. So A equals 104 minus 56, and I get 48 degrees. Whoops, and I forgot to set it, but wait, I didn't write it. Multiply by 2. Pretty easy, right? All right. So we're going to talk about a couple of corollaries, some extra theorems, bonus theorems. So everybody good with this example? All right. So our corollaries. Corollaries just mean extra things that we can figure out easily. I like to think of them as bonus theorems. So we have 3 corollaries that we're going to talk about. 1, inscribed angles that intercept the same arc are congruent. So our picture there, so there is one angle that intercepts this arc, and here is another angle that intercepts this arc. So I'm going to call this angle A and angle B. Angle A and angle B both intercept the same arc. So we'd say angle A is congruent to angle B. Because they intercept the same arc, they have to be congruent. Because to get to both angles, we divide the arc by 2. We're dividing the same thing by 2, so they have to be the same. All right, questions on that corollary? That bonus theorem. Pretty easy idea. All right, let's look at the next one, the second corollary. An angle inscribed in a semicircle. Is a right angle. What's a semicircle again? Half a circle. So here's our picture for this one. There's my circle. There's the center. I'm going to divide it into 2 semicircles. And there's my angle inscribed in a semicircle. That angle has to be a 90-degree angle. We call that angle C. We can say the measure of angle C is 90 degrees. And this makes sense because how many degrees is half a circle? 180. To go from the arc to the angle, we do what? Divide by 280 divided by 2 is 90. There you go. That's why that works. So that's why we call it a bonus theorem, because it's really easy to figure out from our original one. All right, we good there? And our last corollary. The opposite angles. Of any polygon, not any polygon, any quadrilateral, inscribed in a circle, are supplementary. Supplementary means add to 180. All right, so our picture here. We have a circle, and we have any quadrilateral. Quadrilateral means 4 sides. Any 4-sided shape. I can inscribe any 4-sided shape into that circle. And this tells us that the measure of angle A plus the measure of angle C is 180. And the measure of angle B plus the measure of angle D equals 180. Doesn't matter what the quadrilateral is. I can inscribe any quadrilateral in my circle. All right, we good there? All right, let's look at a couple of examples that have to do with these corollaries. First one, this one should be easy. Sure. all the way back here. It was this arc. So they both intercept that, both these angles intercept that arc, so the angles have to be equal. Because we're dividing the same arc by 2 to get each one. All right, are we good? Everybody good? Okay. All right, so this one, hopefully this one's easy. Here's my circle. Here's my center. And I'm going to say 1. Find the measure of angle 1. So what's that angle going to be? 90 degrees. Why? It intercepts a semicircle. So this is a diameter. It goes through the center. So this arc is a semicircle. So that has to be 90 degrees. That one's pretty easy to figure out. One thing I wanted to warn you guys about when we're working with these circles moving forward, unless the picture shows you the center of the circle and your segment going through the center of the circle, don't assume that some line drawn through the circle is a diameter. So make sure that you know that segment goes through the center of the circle before you assume it's a diameter or a radius or something like that. It's an easy mistake to make, and they'll try to do the problems so that they draw a chord that kind of looks like it could be a diameter, but unless you know for sure, don't assume that it's a diameter. Okay? So avoid that mistake. All right, the second example here, and we're almost done. And we want to find the measure of angle 2. Any ideas what we're going to do here?
Oh. You could do like 43 times 2 bigger than
Okay, so Danny says if I look at this, let me get my highlighter, this angle, I multiply by 2 to get to the arc. So that arc has to equal what? 86 degrees, and what's your idea, Carolyn? They intercept the same arc, so I think you're thinking the same thing, but you were figuring out the arc and then the angle. But you can also say they intercept the same arc. They both intercept this arc AB. They intercept this arc. Since they intercept the same arc, they have to be the same. So you could say right away that the measure of angle 2 is 43 degrees. And if you didn't see that right away, you could say, oh, well, this arc equals 86 degrees because I multiply this by 2. And then to get back to the angle here, what do we do to go from the arc to the angle? Divide by 2. So 86 divided by 2 is 43 degrees. So you can do it either way, and either way is just fine. So if you see it right away, you're fine because they intercept the same arc. Otherwise, you can figure out what the arc is and then divide the arc by 2 to get the other angle. All right, questions there? All right, our last theorem. This one doesn't have a special name, so I'll just call it a theorem. And I just want to point out that this one is really not different than the first one we talked about. So we're going to say the angle formed by a tangent in a chord is half the intercepted arc. So let's draw a picture of what we're talking about here. What's special about a tangent to a circle? Touches at exactly one point. So here's my tangent. And then here is my chord. So there's the point where it's tangent. I'm going to call that point A. We'll call this point C, and this point B. Where's the vertex of this angle BAC in relation to the circle? A. And is A in the circle, outside the circle? On the circle. The vertex is on the circle. Just like an inscribed angle. The rule is exactly the same. So what this is saying is that the measure of angle BAC is 1/2 the measure of arc AB. Here's my intercepted arc. It goes all the way from the vertex to the other side of the circle. There's my intercepted arc. But the angle is half that arc. And we could turn it around just like we said before. Or the measure of arc AB is 2 times the measure of angle BAC. So our rule is exactly the same. To go from the angle to the arc, multiply by 2. To go from the arc to the angle, divide by 2. The vertex is on the circle. It's the exact same rule. The only difference here is that this piece of the angle is outside the circle. But our vertex is still on the circle. All right, questions there? And before we do an example here, our last example, I just wanted to go back to our picture of our inscribed angle. Just so we know, the way we proved this idea with the angle and being the angle being half the arc, is we would draw a central angle, and it has to do with breaking this up into triangles using a central angle. And that's how we do the proof. So we break this up into more triangles, and that's how we decide that the angle is half the arc. I just wanted to point that out. All right, so let's look at one example having to do with a chord and a tangent, and then we're done. Isn't it fun drawing all these circles? I like drawing all the circles. All right. Whoops. That one. And so here's a point A on the line. There's a point B on the line. We'll call this C and point B. and I'll call this point E. We might need that one in that one. And I'm going to say that line AB is tangent to the circle at C. The measure of, I guess we do need this one, the measure of arc CED is 214 degrees. We want to find the measure of angle DCB. So what this is telling us, so I'm going to highlight here, this arc CED is 214 degrees. And we want to find the measure of this angle. Couple of ways that I thought of to do this. Anybody have any ideas? Yeah?
I would divide 214 by 2 to get angle ACD.
Okay, so we're going to go from the angle, or sort of the arc to the angle, divide by 2. So we could say the measure of angle ACD is 214 divided by 2, which is 7 degrees. So we know that one is, we figured out that's 7 degrees. Okay? And then what?
And then since that angle and that angle next to it is supplementary, you subtract 107 from 180.
Right. These are a linear pair. So if they have to add up to 180. So the measure of our angle DCB is 180 minus 107, which gives me 73 degrees. Anybody see a different way to do it?
Do like 360 minus 240.
Perfect. So what Porter says is all the way around the circle is 360 degrees. So we can figure out the measure of this arc. This is 360 minus 214, which is 146 degrees. So that arc is 146 degrees. And then to get from that arc to that angle, divide by 2. And I'll do that in blue because that's our different technique. 146 divided by 2 is 73. So we can do it either way. And it all has to do with multiplying and dividing by 2. All right, questions on that example? Okay. Homework. Actually, should we not call it homework? Should we call it classwork? All right, and just a reminder, do at the end of period. And what did I